friends, in this lecture we will see what is elementary matrix and types of elementary matrices. So first we will see what is elementary matrix. Elementary matrix. An elementary matrix is a square matrix that has been obtained by performing an elementary row or column operation. That is a matrix obtained by performing elementary row or column operation on an identity matrix. So consider the identity matrix of order 2, that is I2. So there are only three row operations, that is interchanging of two rows, multiplying a row by a non-zero constant, and multiplying any row by a non-zero constant and adding to other row. So we get only three types of elementary matrices. See here, first example, performing the row operation, interchanging the two rows. If we interchange these two rows of an identity matrix, then we will get these two rows. Then we will get this matrix. It is denoted by E12. This is the notation, because E12 means E means elementary matrix obtained by interchanging first and second row. So interchanging 1 0 now becomes first row because we have interchanged to 0 1 and 1 0. This is the one type of elementary matrix. Similarly, the second operation is multiplying a non-zero constant by multiplying any row by a non-zero constant. So in this example we have multiplied second row by 2. So this is the matrix. This is denoted by E22. E22 means what? E is the elementary matrix, 2 means second row, and multiplying 2 by second row by a 2 non-zero constant. So multiplying second row by a non-zero constant, we get 0. This is 2. So this is another type of elementary matrix. Third one is perform the operation multiplying first row by minus 2. Multiplying this matrix, elementary matrix, first row by minus 2 and add to the second row and adding to the second row. So what we get? We get R2 plus minus 2R1. Implies R2 means what? The effect is on R2. This can be, in short notation, we will get a matrix. E21 minus 2 means what? Multiplying this first row by minus 2 and adding to the second row. We get this matrix 1 0 and minus 2 comma 1. These are the three types of elementary matrices. Okay, students. So types of matrices here. Types of matrices. Types of matrices. Elementary matrices. Consider an identity matrix of order n. There are only three types of elementary matrices. Eij, we have already known that. E12. Eij means what? The elementary matrix obtained by interchanging ith and jth row of in. In is what? Identity matrix of order n. Ejc. Ejc is the elementary matrix obtained by multiplying jth row by a non-zero constant c. This must be a non-zero. Keep in mind, this must be a non-zero. EIJC means what? EIJC means elementary matrix obtained by multiplying jth row. So see here, multiplying jth row by a non-zero constant c and adding to this ith row. These are the only three types of elementary matrices. If we take the identity matrix I3, here identity matrix I3 is 1 0 0 0 0 1 0 0 0 1 and multiplying its first row by 3, we obtain the elementary matrix E13. This is denoted by E13. This is denoted by E13. So how we will get E13 is just multiplying first row by 3, we will get, this is 3 here. So first row is 3 0 0 0 1 0 and 0 0 1. Similarly, multiplying first row by minus 4 and adding to the third row, obtain the elementary matrix E31 minus 4. So here E31 minus 4 is multiplying first row of this matrix by minus 4 and adding to third row. What you get? This is multiplying this by minus 4 and adding to third row means First row is as it is, second row is as it is, third row becomes minus 4, 0, 1. Similarly, interchanging first and this third row, we obtain the elementary matrices E12. This is called the E12 matrix. Just interchanging the first and third row of this identity matrix of order 3. These are the more examples on elementary matrices. Next one is elementary matrix is invertible. Is elementary matrix is invertible? That is inverse of elementary matrix exist? See here an example. First we consider an example. Consider a matrix E12. E12, this is I2. E12 is just interchanging first and second row of this I2. Okay. So we get this matrix. Okay. So multiplying E12 by E12, what we get? Multiplying E12 by E12, first row, first column, 0 into 0, 1 into 1, we get 1 here. First row, second column, 0 into 1, 0, 1 into 0, 0. 1 into second row, first column, 1 into 0, 0 into 1, again we get 0 here. Similarly we can get 1 here. Okay, so this is nothing but I2 identity matrix. So similarly we can obtain, so what do you think? When a matrix is invertible, if there exists another matrix such that product of these two matrices is an identity matrix. Order is immaterial where the product AB or BA. So inverse of E12 is E12. Again, for the elementary matrix E23, E23 means what? Multiplying the second row by 3, this matrix, we will get this matrix. So consider here E23 into E21 by 3. E21 by 3 means what? Multiplying the second row of this matrix by 1 by 3. What you get? This is just here 1 by 3. This here 1 by 3. We will get this 1 by 3. Okay. So multiplying these two, first row, again first column, 1 into 1, 0 into 1 into 1, 1 here, 1 into 0, 0. First row, second column. Second row, second column means 0 into 1, 0, and 0 into 0, 0, 3 into 1 by 3 is 1. Similarly, E2 1 by 3 and E2 3, we will get identity matrix. So inverse of E2 3, inverse is E2 1 by 3. Inverse of this matrix is E2 1 by 3 because product of these two matrices we get identity. Similarly, for the matrix E2 1 minus 2, E2 1 minus 2, we have E2 1 minus 2. E2 1 minus 2, how we can obtain E2 1 minus 2? This is 1 0 0 1 multiplying this first row by minus 2 and adding to second row. This is multiplying first row by minus 2 and adding to second row. So we get minus 2 here. Consider a matrix E2 1 minus 2. E2 1 minus 2 is obtained by multiplying first row by E2 1 2, multiplying first row by 2 and adding to the second row. So take product of these two matrices. What you get? Again you will get on the same manner, you will get the identity matrix. So you have seen here E2 1 minus 2 inverse is E2 1 2. You have seen here what you have noted is elementary matrices are invertible and inverse of an elementary matrix is again elementary.